Let's talk about tokens and capacity because it really matters about how much you can produce. So, when using transformers, the decoder continuously feeds the sequence of tokens back in as the output to help predict the next word in the input. So, what are we talking about here? So, here, imagine we have our input as the quick. And so we feed into the encoder. The encoder is going to produce semantic context so that the decoder knows what to do with that text. And then the decoder is going to output the next word. So this is the quick brown. And what it does is it feeds that sequence of tokens back into the decoder and produces the next word and again and again. And so the question is, what is the capacity required to run this? And so there are two components that we care about: memory and compute. So for memory, each token in a sequence requires memory. So as the token count increases, the memory increases. The memory usage eventually becomes exhausted and you cannot produce anymore. Okay, so now for compute, models, a model performs more operations for each additional token. The longer the sequence is, then the more compute is required. So a lot of AI services that offer models of service will often have a limit, a combined input and output, because it really has to do with the length of the sequence. So if you have a huge input, then you're not going to be able to generate a lot of words because you're going to hit that sequence token limit a lot quicker. So hopefully that makes it very clear about how memory and compute are intertwined with tokens. The way cost gets down is, they have to figure out a way of reducing or making the model more efficient. So that's helping to reduce the memory compute. There's other things you can do. So if you have a conversation that gets too long, what you can do is summarize the conversation and feed it back into there. So it doesn't exactly use all of the context of what it had before, but it can do something similar and help that conversation along, okay?